Most container homes don't fail because of rust, foundations, or bad welding. They fail because of one structural cut that breaks the load path. Shipping containers are not built like houses. They are semi-monocoque structures where every corrugation carries load. When you cut the wall without replacing that stiffness, failure is not immediate. It shows up months later when doors stop closing and the structure slowly deforms. In this video, I'll show you why that happens and how engineers prevent it. To understand the danger of a single cut, you must first unlearn everything you know about a traditional wood frame house. A house is a skeleton of beams and columns covered in a non-structural skin. A container is the opposite. It is a semi-monocoque structure. The term comes from aerospace engineering. Monocoque means single shell. The strength is not in a separate internal frame. The strength is the shell. The corrugated steel walls are the primary load-bearing members. Each individual corrugation, every single fold in the steel, acts as a small vertical stud. These corrugations work together as a single, massive structural panel designed to transfer the immense loads from the roof and sides down to the corner posts and the main floor rails. Think of it this way. The container is not a box. It is a precisely engineered, hollow steel beam. Now let's talk about the load path. This is the invisible highway that structural forces travel along. In a container, vertical loads from snow or stacking and horizontal loads from wind are distributed across this entire corrugated skin. The forces flow uninterrupted down these vertical studs of steel to the massive rails at the bottom and top. This continuous, unbroken path is what gives the container its phenomenal strength. It's an incredibly efficient system. But it has one critical vulnerability. It relies on being whole. The moment you take an angle grinder and cut through that wall, you are not just making a hole. You are dynamiting a section of that structural highway. You have just created a dead end. This is the fatal mistake. When you interrupt the load path, the forces that were once distributed across the entire panel now have nowhere to go. They concentrate at the edges of your cut, creating immense stress points. When you cut, say, 2 meters of wall for a large window, you may be removing 10 to 15 of these load-carrying corrugations. The vertical load from the roof that was once supported by that section is now pushing down on an empty space. The container doesn't collapse immediately. This is what deceives so many builders. Instead, you get progressive deformation. The roof rail will begin to sag, almost imperceptibly at first. The floor rail may begin to deflect upwards. The entire structure begins to slowly twist under this new, unbalanced load. Months later, the symptoms appear. Doors that jam, windows that crack, and a floor that feels bouncy. The failure was not in the materials. It was in the misunderstanding of this one critical principle. So how do engineers solve this? They don't just add a frame. They create a new engineered load path. The guiding principle is this: the stiffness you add must match or exceed the stiffness you removed. This is why simply welding in thin, undersized steel tubes is a common but critical failure. The amateur thinks about strength, but the engineer thinks about stiffness, the resistance to bending and deflection. The professional solution is to design and weld in a new heavy-duty frame of thick-walled rectangular steel tubing, or I-beams. This new frame is not just a window trim, it is a structural bypass. It is engineered to capture the load from the interrupted corrugations above it, channel those forces down its vertical members, and reintroduce them safely into the main structure below. It is a carefully calculated bridge built to restore the integrity of the highway you were forced to cut. In the end, the structural integrity of a container home is not a matter of guesswork. It is a matter of respecting the engineering that makes it strong in the first place. The failure of most modified containers is not a mystery. It is the predictable consequence of breaking the load path without restoring the stiffness. The difference between a lasting, valuable structure and a slowly deforming liability is the understanding that you are not modifying a simple box, you are performing surgery on a highly efficient semi-monocoque machine. And in that surgery, the engineer's scalpel will always be superior to the amateur's sledgehammer.